Okay, good morning everybody. So today we'll start with designing of the Turing machines. Okay. For designing the Turing machines, the things that you have to remember is the fundamental objective is scanning the symbol by using the read and write head, and also to know what to do in future. Means whenever you are designing, you have a question, so you will obviously there will be strings which either you have to accept or reject, right, based on that, or some things that you have to do on strings. So when you have strings, something, let us say w, some kind of a string. Okay, so the objective is using the read and write head, look at a symbol. Okay, and then we should also know what to do about this. So sometimes, for example, we may be replacing this by something else, right? Or converting, it could be anything, other symbol like E, or you can even write a blank in place of that. So various other things. And also, if there is something unique that we do, if we have to remember what we have done, then we may have to change the state. So basically, fundamental objective is scanning the symbol to know what to do in the future. So if we must remember past symbols that are scanned, so this remembering is done by going to some other unique state or change the state. And next objective is that we should write it using as less states as possible. For example, you change the state only when there is change in written symbol, when you are replacing, or when you are making a movement. Okay, otherwise don't change. For example, if you are doing the same action throughout, let us say you have this something like this, and you have to just move towards B, and your action, and the only action that we are going to do is moving towards right till I come to B, and I'll do something else when I come to B. So for all these four things, I'm just moving towards right. So if you have like that, then do not change the state in this. Change the state when you come to some other place and you do a perform a unique action. Okay, I hope this is clear for you. So let us design a few, one or two Turing machines today. So this is your first example. Design a Turing machine to recognize all strings consisting of even number of ones. Now the question is, do I require a Turing machine for this? I do not, okay? Because you have already seen that we can do it using the simple CFG also, or even you have written a DFSM for that, isn't it? So what did you do for DFSM? You took something like this, no? Let us say you are in state Q1, right? And if you get one, because we are talking about even number of ones. So for every odd number of ones, you will make a change of state to Q2. Okay. And when you get the next one, which will make it as even, you will come back to state Q1. So I'll make Q1 as the final state, correct? So that it accepts only even number of ones, isn't it? So if I have just one, I'm going to make a transition to Q2 and it will be rejected. If you have one, so I come here and come back, so it will be accepted. Four ones also, you can see that Q1 to Q2, Q2 to Q1, Q1 to Q2, Q2 to Q1. So ultimately you will be in the final state and it will be accepted. Okay. So this DFA we have already designed, but we'll start designing Turing machines with simple examples. That's why we have taken this. Not a lot of state changes are required for this example. We'll increase the complexity as we move ahead with the class. So how can I do the construction? Let us frame the moves that we are going to make in our mind. Okay. So the first step is always to define the moves. What are the various things that I'm going to do when I design the Turing machine? So let us use this diagram itself, what we have drawn over here as a reference. So the first thing we did there is selecting Q1 as a initial state, correct? No? So you selected Q1 as starting state or initial state. So we selected this. What is the next thing you did here? So if you are in initial state and you scan 1, then you will change the state to 2, isn't it? So if you are in this initial state Q1, on scanning symbol 1, you change state to 2, isn't it? You move to Q2, right? What else you are going to do? So when you are in state 2, on scanning 1, you move back to state Q1, right? On scanning 1, you move to Q1, isn't it? So that's all we are doing. So when will you which is the accepting state here? So in this particular diagram, Q1 is the only accepting state. Why I'm saying only is because you can have more than one accepting states. In the definition of Turing machines, you saw that, isn't it? You can have more than one accepting state. So Q1 is the only accepting state. Okay. So when do we say we accept this string? If all inputs are exhausted and we are in state Q1, only then we say we accept this string. So how do I symbolically show this? Symbolically means using the definition of Turing machine, right? How do we show what are the various things that are there in this particular thing? So I will write it here. So I will say the machine M. So initially we'll have to mention how many states are there, isn't it? So how many states are there here? Q1 comma Q2, two states are there, correct? And then what are the input symbols and what are the so, so in this case, for this particular example, right? What are the input symbols and what are the tape symbols? Those things you have to mention, right? And then you have to actually design for delta. And then what is the initial state, a blank symbol, and what is the final state? So let us write about two of those. That is, what are the input symbols and what are the tau. That is, I'm talking about sigma and tau. We'll write it later. But whatever we know, delta I'm going to design, and we are sure that the starting symbol is Q1, right? And B always remains as a blank. I mean, what symbol I use to represent a blank? So I'm going to use B itself. And what is the set of final states? In this case, final state is also same as the initial state. All right. So after keeping this, let us actually continue designing. We'll come back and fill that later. So let us write the transition table for this Turing machine one. So in transition table, what will be there in the row? You will have states. So in this case, you have only two states, Q1 and Q2. And what will be there in the column? In column, you will have tape symbols. Correct? You will have tape symbols. So for this, because you see the logic says scan 1 and scan 1, we are talking only about scanning 1. So we are going to use only one tape symbol, which is equal to 1. Okay, which is equal to 1. So if you have 1, the logic that we are going to use is Q1 on 1. All right. If you have 1, then I am going to replace it by a blank. All right. And then I make the change of state to Q2 and I'll go to R. So let us say the logic we are going to use is if you have ones, ultimately, we are going to, if this is 1, I'm going to write it as a blank and move ahead. When initially I'll be in Q1, then I'm going to move ahead to Q2. Okay. If you get Q2, I'm going to replace this by blank. Okay. And then again I go to the next one and I'll come back to Q1. So Q1 if you have, again replace it by a blank, go to Q2, and Q2 you get a blank, again come back to Q1 like this. Okay. So we're going to do this. Is this the only way? No, it's not the only way. This is one of the ways that is mentioned in your textbook. With confidence that you are going to gain after designing 3 or 4 Turing machines, you can write these in different ways as well. Okay. So as of now, if you are in state Q1, which is both initial state as well as the final state, so whenever you are in state Q1, if you get an input symbol 1, then replace it by a blank, change the state to Q2 and move towards right. You can also write it as BRQ2. Okay. In your textbook, in some places he has used the first notation and in some places he has used the second notation. So we'll stick to one notation. Okay. We'll use this BR and Q. So blank, move towards right and change the state to Q2. So what will you do when you are in Q2? Same thing, isn't it? Replace it by blank and move towards right and change the state to Q1. Okay. So this is all your Turing machine is. All right. This is all that we are going to do in the Turing machine. Now, the tape symbols are here. Tape symbols are blank and 1, and the input has only 1 as the symbol. Okay. So that has been completed. Now let us take a few strings and use this Turing machine that we have designed to see how it accepts or rejects something. Okay. How it accepts or rejects something. So let us first just take just one. Okay. We are in the initial state and we have taken the symbol as 1. Okay. If you have 1, so Q1 on 1. What does it say? Replace the 1 by blank, correct? And move towards right side. That means come here. Change the state to Q2. So it becomes BQ2 and 1. BQ2 and 1. Now you have the state as Q2 and the symbol is 1. So what does it say? Replace this 1 by a blank. Okay, the second one by a blank. Move towards right and go to state Q1. And go to state Q1. Correct? So now you are in this state. Now input is exhausted, right? Now since the input is exhausted, means we have consumed the input. What is the state we are in? We are in state Q1. So when input is exhausted, we are in state Q1, and since Q1 is final state, string 11 is accepted. Now let us take one more example. Okay. So we'll take, starting from the starting state, we'll take 3 ones. So if you get first one, what will happen? It will be blank, state changes Q2 towards the right and you are left with 2 ones. Next, Q2 on 1, again the second one is converted to blank. You have moved towards the right and change the state to Q1. Now you got Q1 on 1, so that 1 is also converted into a blank. You move towards right and change the state to Q1. Now what happens? Input is exhausted, correct? Input is exhausted and we are at state Q2. And since Q2 is not a final state, the string 111 is rejected. And it makes sense. Why? Because the question was to design a Turing machine to accept even number of ones. So the first one was even. So it is accepted. And you can see this is odd. So it is rejected. Okay. So now let us move on to the next example. Let's take one more example. So design a Turing machine over the input 1 comma blank, okay, which can compute concatenation function. You have string cat, no? Similarly, concatenation function over sigma is equal to 1. Okay, so this is your tau, this is sigma. All right. Now, if let us say there is a pair of words, okay, both will contain only one because the input has only one. So if a pair of words w1 comma w2, that is there are two strings, one is w1 and second one is w2, is input, then output will be, or it has to be, just w1 followed by w2. So this is concatenation function. So how can I show this using tape? Okay, how can I show this using the tape? So we are assuming that, see, we have two strings. Let us say we have a string 1 like this, and then after a blank I might have the second string. Okay, this is my input tape which is ready. So what will be my output tape containing? It will have 5 ones. Okay, and maybe before and after this blank. I hope this is clear. So this is your W1. After a space, you have W2. And this is your concatenated string W1 followed by W2. Okay. So we are assuming initially, when we are solving the problem, no, we are assuming that the input is in tape like this and it is separated by blank or a symbol called as B. Okay, I hope this is clear to you. So what is the task that we have to do to convert this to this? Okay, if you know the tasks, then designing becomes easy. See, it's quite simple. This blank is replaced as 1, isn't it? Separating symbol. In this case, I mean, indexing doesn't make sense in this example. Just to show you the positions I have written, okay? Just to write the positions. So you can see here at 2 blank was there and it has to be replaced by 1. So this is my first task. Okay. So separating symbol must be replaced by 1. Correct? Must be replaced by 1. And what happens to ones? Whenever you have 1, you do nothing. You just move towards right side. Isn't it? So, if you see this rightmost one, this fifth position what I have shown here, it has to be replaced by a blank. That's your another task, right? So, rightmost one must be replaced by blank. Okay. And then also there's one more assumption that we do. See, string concatenation when you use in data structures or when you write using C, after concatenating, no, you should always come back to the first position. That's what is returned. Okay. I hope this is clear. So even in C, after you concatenate, you return the concatenated string back to display or whatever. So that should be always, the position should be returned to the first character. Okay. That's what we are going to do. Okay. So that is our third assumption. The read and write head returns to starting position. I hope this is clear. Okay. So how can we write the transition table for this? Let us take the table will have present states in the column and tape symbols in the row and tape symbols in the column. The two tape symbols that we are using here, you can see both one and blank is used, right? So we are going to use both the tape symbols, one as well as blank. So I'll have two columns. And how many states are required as we develop the logic in your mind, we can go on doing. So let us start with Q naught being the starting state. Okay. So Q naught, what will I do here? You see, whenever I get one, I just move towards right, isn't it? There's no other action required. It is the same action that I'm going to do for every one. So Q naught, when you get one, all that you do is move towards right. So I am not replacing anything. I'm not doing anything extra. So I'll keep it as state Q naught itself. Okay. So after that, you can see when I get the B, I'm doing some changes, isn't it? Right? I'm doing some changes, and after doing that change, I have to again move towards the next symbol, towards right only. So what will I do? If at all I get a 1, if at all I get a blank, the blank is replaced by 1, right? And I move towards right and I make it as Q1 because I have made some change, right? I have made some change. So next, what has happened? I am in now state Q1, isn't it? Let me write it here itself. It's more easy for us than going forward and coming back. Let us say this was our first one, and this was our second string. This is W1 and W2. Okay. So far we wrote the logic starting from Q1. I'm just moving forward, and when I got this blank, right? And you can see I replace that blank by a 1. I replace that blank by a 1. Sorry, we started with Q naught. So after replacing it by 1, I move towards right and I change the state to Q1. This is what we have written, isn't it? So now when you are in Q1, if you get 1, what will you do? Again, you will move ahead itself. So if you get 1, you are going to move towards right itself till you get a blank, no other change. So I got 1, right? Now I got a blank, right? I got a blank. So when I get a blank, what I have to do? This blank is replaced by 1. So I should have totally 5 ones, but now I have 6 ones. So I have to come back and make change to this, isn't it? I have to convert this also into blank, right? So what will I do if I get a blank? If I get a blank, this blank, I'm not going to change anything. That will remain as a blank. But I have to come back to this one. So I have to make a left side movement, isn't it? I have to come to left side movement. So this is a different action. So I'll go to state Q2. That means when I come back now, when I come back now, okay. So when I come back, I change the state to Q2. Okay, I come like this. That means now I have Q2 and a 1, isn't it? And what should this 1 become? It should become a blank. So that 1 becomes a blank now, right? It is made as blank. So now I have how many ones? I have 5 ones as required. So the last one is now converted into a blank. Now it is a different action, isn't it? So since it is a different action, I'm going to change the state to Q3. And as I told you, we will be coming back to this position, initial position. That means from there, I'm going to make movements towards left. Okay. So let us say now we have Q3 on receiving 1. So I changed state to Q3. On receiving 1, I should just keep coming back, right? Left by one position, make no other changes. So if you have 1, just keep moving towards left. Don't need to change the state. So when will I make any change is when I get this blank. So if I get that blank, right, when I'm in Q3, if I get a blank, starting position is this, isn't it? Starting position is this. So I move towards R and I change the state to Q1. I change the state to Q, or let us say we change the state to Q final, something like that. That's our final state. Okay. I'll repeat this once more for you. So if you had anything that you didn't understand earlier, you can understand it better now. I'll repeat it once more. We'll draw it below. Okay. Lot of time gets wasted. So as we started with, let us take one more example. Okay. Let us say initially we are like this. This is the tape symbol. Starting with the blank. My initial state is Q1 where the string starts. Let us say the first string has 3 symbols. This is W. Okay. And then we have assumed that after this blank, we'll have W2, correct? So we'll have W2 and then there will be a blank. My job is, as we have seen, to convert this blank into 1, this one into blank, correct? So when we determine the logic, we wanted to convert this blank into 1 and this 1 into blank is what we are trying to do. Okay. So we'll start with Q1. So obviously in row, what will you have? In the transition table that we are going to design, in the transition table we are going to design. So in the rows we'll have the states, correct? So we'll have states. And in columns, if you observed in the question, so we usually we give the tape symbols and we are going to use both symbols, isn't it? I'm going to use 1 also and blank also. So you will have to write it for 1 as well as blank. So initially start with Q1 or Q0 or whatever you want to start with. So let us start with the Q0. So if I start with a Q0, all that I am going to do is move towards left. Okay, move towards left till I come to blank. So whenever you have 1, okay, all that you are going to do is keep that 1 as 1 itself. Move towards right, no need to change state because you are doing nothing, no replacement, no change of action also. Means till now we were doing right side and I'm deciding to go towards left. No major decision like that. So we'll keep it as Q naught. If you get B, what will you do? You have to replace B by 1. So I replace B by 1 and then I have to continue moving towards right itself. But now it's a replacement. So a major change that has happened. So let us change the state to Q1. Okay. Again, when you have 1, what will you do? You will just move, right? You will just move till where? I'll move till I get a blank symbol. So if you have 1, just move towards right. And what is the state we are in? Q1. So no major change. So just move towards right. Now you got this blank and now you know the end of input has occurred. You have completed scanning all symbols of W2. So do I change this blank? No, it remains as it is. Then what do I do? I have to come back and make this as blank, isn't it? So I have to come back. So since it's a different decision that I'm going to make, so obviously I'm going to change the states now. Okay, I'm going to change the state. So now what will I do is on my way back, when I'm coming towards left, so when I came here, it was Q1. When I come towards left, I'll make a move to a state called as Q2. Okay. Now in Q2, what will happen? We have already replaced this blank by 1, isn't it? So when I come this side, this symbol has to be converted into blank, right? Which is 1. So if you get 1, convert it into a blank. After this, I have to move towards left, isn't it? Because I want to return this position, initial position. So I am going to move towards left. And because it's a different thing that I'm going to follow from here, so I'll change the state to Q3. All right. So now let us come to Q3. In Q3, for each one, you're just going to come till you reach the beginning. So how do I know I reach the beginning? I won't know I'll reach the beginning until I hit a blank. Okay. I won't know I reach the beginning until I hit a blank. So when you are in state Q3, if you get 1, you just keep moving towards left and remain in Q3 itself. When I hit a blank, you know that I have to return this position, isn't it? So I have to move towards right, and that's my final answer, right? So if you have a blank, of course, I'll not change blank to anything else. It will remain blank. I have to move towards right, and let us say we reach some stage called as QF. You can also put it as Q4 if you want, and you can put a circle. So that means I am here. And after this, nothing. It is an acceptance. Okay. It is an acceptance. Let's take one example fast and trace this. So let us take, we have started at Q0. We have 2 symbols, a blank. Okay. And then again, let us say I have 3 symbols. Okay. So Q0 on 1, right, and Q0. So 1 Q0, 1 blank, 1 1 1. Again Q0 on 1, just move towards right with Q0 like this, isn't it? Okay. Now Q0 on blank, that blank is returned to 1. The blank third symbol has become 1. Move towards right with Q1, right? So 1 2. Isn't it? So in the end, you'll have a blank as well. So after the second string, you have blank. So we can write it here itself, or we can assume it when we go to that position. So Q1 on 1 is just let it be 1. The fourth one comes here and you move towards right. So again Q1 on 1. So you have all 5 ones placed in one place. Correct? So you have this has become 1, then uh, 3 ones. So I wrote it as 2 ones here. Okay. So 3 ones. So 1, 2, 3, 4. I'll have one more. And then it has become 6. It should have become 5 ones, but it will become 6 ones. Isn't it? It will become 6 ones. Now what have I reached? I have reached Q1 on a blank because nothing else is there. So on reaching Q1 on a blank, what will you do? You move towards left and call that state as Q2. So you will have 5 ones, 1, 2, 3, 4, 5 ones, and then this will become Q2 and a 1. Correct? 1, 2, 3, 4, 5, and you came towards left and you change the state to Q2. So what is Q2 on 1? You will make this as blank. So after making this as blank, you are moving left and making it as Q3. So you have to move left here and make it as Q3. So 1, 2, 3, 4, then Q3, and then you made that symbol as a blank, isn't it? You made this one as a blank. Okay, so this is a blank. And from here you move towards left. Now what about Q3 on 1? You can see till you get a blank, it will just be moving left. So 1, 2, 3, Q3, 1, 1, right? Then again 1, 2 ones and Q3, triple 1. Then 1, Q3 and 4 ones. And then obviously blank, right? Q3 and 5 ones, right? And again Q3 blank followed by 5 ones. So what is the action we have written for Q3 on blank? Move towards right and call it as a Q final, isn't it? So I have to move it here and call it as a Q final. So Q final 1, 2, 3, 4, 5. So if you have reached the final state for this question, it is accepted, and also we have returned the first position after concatenation. Okay. I hope you have understood whatever I have done in today's class. We'll do some more designing tomorrow.